Hello friends, I welcome you in lecture number 2 on system of linear equations. In previous lecture we have discussed what is system of linear equations, and we have seen for every system of linear equations there are three types of solutions. Either the solution of the system is unique, or system has no solution, or system has infinite number of solutions. So today we are going to discuss about Gauss elimination method for solving system of linear equations. So we will discuss all the cases one by one. In this lecture we will discuss two examples of systems having unique solution and no solution. In next lecture we will discuss the example of system having infinite number of solutions using Gauss elimination method. So this is general method for solving system of linear equations. We understand this method with the help of example, and this method is also known as Gaussian elimination method. For this method we are going to use row echelon form of a matrix. So you must be familiar with row echelon form of a matrix, or you must be able to find out row echelon form of a given matrix. So if you are not familiar with this row echelon form, I suggest you to watch my earlier lecture on row echelon form so that you are able to understand this Gauss elimination method. So with this, now we discuss Gauss elimination method with this example. So the idea of Gauss elimination method is to construct the another system which can be easily solved, and that system has the same solution as the given system. So first step of Gauss elimination method is to write the matrix corresponding to given system. That matrix is written as, first we write down the first column of the given matrix. So the first column of the matrix corresponding to given system is coefficients of x. So here coefficients of x are 1, 2 and minus 3. Second column corresponds to coefficients of y, which are minus 3, minus 4 and 6. Third column corresponds to coefficients of z, which are minus 2, minus 3 and 8. And the last column corresponds to constants on the right hand side. So in this way, first we have to write down the matrix corresponding to given system. That matrix is known as augmented matrix. Augmented matrix of given system. So it is written in this way. First column of augmented matrix is coefficients of x, which are 1, 2 and minus 3. Second column corresponds to coefficients of y, which are minus 3, minus 4, 6. Similarly, coefficients of z are minus 2, minus 3 and 8. And the last column corresponds to constants on the right hand side. Now, second step is to convert this augmented matrix into row echelon form if we are using Gauss elimination method. So now we try to convert this matrix into row echelon form. So we start with first non-zero entry of first row. It is 1 here. So using this entry we have to make these entries 0 which are below to this entry. So to make this entry 0, I have to multiply this 1 by minus 2 and add in second row. So the operation required is multiplying first row by minus 2 and adding in second row. Similarly, to make this entry 0, I have to multiply first row by 3 and add in third row. So if I take these operations, second and third rows will change, first row remains as it is. So we write first row as it is. Now we multiply first row by -2 and add in second row. So therefore here 1 into -2, which is -2, plus 2, which is 0. -3 into -2, that is 6, -4, 2. -2 into -2, which is 4, and -3, that is 1. 6 into -2, that is -12 plus 8, which is -4. Now we multiply first row by 3 and add in third row. So here 1 into 3, which is 3, -3, so we obtain 0. -3 into 3, which is -9, plus 6, that is -3. -2 into 3, which is -6, plus 8, that is 2. 6 into 3, which is 18, minus 5, which is 13. So after applying these two elementary row operations, we come to this matrix. It is equivalent to augmented matrix. So the first non-zero entry of first row has zeros below that entry. Now we come to the first non-zero entry of second row. So we must have this entry 0. So to make this entry 0, we have to first multiply this by 1 by 2, or divide this by 2 and multiply with negative of -3, which is 3 by 2. So if I multiply this 2 by 3 by 2, I will obtain 3, and if I add that multiple here, I will obtain 0. So next operation is multiplying second row by 3 by 2 and adding in third row. Multiplying second row by 3 by 2 and adding in third row. So third row will change, first and second rows remain as it is. So we write 1, -3, -2, 6. First row remains as it is, 1, -3, -2, 6. Second row remains as it is, 0, 2, 1, -4. Here we multiply second row by 3 by 2 and add in third row. So it is 0. Now 2 into 3 by 2, which is 3, and add in -3. So we obtain 0. Then 1 into 3 by 2, that is 3 by 2, and adding in 2. So this means 3 plus 4 divided by 2. So we obtain 7 by 2. Similarly, -4 into 3 by 2 plus 13. So here 2 will cancel out and we have -6 plus 13, which is 7. So this entry is 7. So we can see here the first non-zero entry of third row is to the right of the first non-zero entry of second row, and first non-zero entry of second row is to the right of the first non-zero entry of first row. So this is now row echelon form, which is in row echelon form. So the first step of augmented matrix is to write down the matrix corresponding to given system. That matrix is known as augmented matrix, and then to convert augmented matrix into row echelon form. Now in the next step we have to write down this system corresponding to this row echelon form. So the system corresponding to this matrix which is in row echelon form is, so the first row is x minus 3y minus 2z equal to 6. X minus 3y minus 2z equal to 6. We give this number 1. First row is 1 into x minus 3y minus 2z equal to 6. Second row is 2y plus z equal to minus 4. We give this number 2. And third row is 7 by 2 into z equal to 7. So now this system is corresponding to row echelon form. It is corresponding to row echelon form of augmented matrix, and this row echelon form is obtained from augmented matrix. So row echelon form or row echelon matrix, that is this matrix, is equivalent to augmented matrix. And here we are using the fact that if two matrices, say A and B, are equivalent, then the systems corresponding to A and B will always have same set of solutions. So that is the idea on which Gauss elimination method works. If two matrices are equivalent, then the systems corresponding to those two matrices have the same set of solutions. So here given system is not possible to solve easily directly. So we are writing the augmented matrix of this system and we find out row echelon form of the augmented matrix. And if we write down the system corresponding to this row echelon form, then that system can be solved easily. And because this row echelon form is equivalent to augmented matrix, both the systems will have same set of solutions. So the idea of Gauss elimination method is to find out the row echelon form of the augmented matrix and to solve the system corresponding to row echelon form. The solution of that system which corresponds to row echelon form will be same as the solution of given system. So after solving this, we are able to find out the solution of given system, because this system corresponds to row echelon form, and because row echelon form is equivalent to augmented matrix, the solution sets of this system and given system are always same. So we solve this system by back substitution. That means we first solve equation 3. By 3 we can see z equal to 2. This 7 will cancel out. Now we put value of z in equation number 2. So by 2, 2y plus 2 equal to minus 4. Therefore 2y equal to minus 4 minus 2, which is minus 6. So 2y is minus 6. Therefore y is nothing but minus 3. Z is 2, y is minus 3. And we substitute values of y and z in equation number 1. So equation 1 is x minus 3y minus 2z. X minus 3 into y. Y is minus 3 minus 2 into z, which is 2, equal to x minus 3y minus 2z equal to 6. So if we simplify this, this is x plus 9 minus 4 equal to 6, therefore x plus 5 equal to 6, therefore x is 1. So here we can see we obtain exactly one values for each variable. X is 1, y is -3, z equal to 2. So therefore we can write the solution of given system is x equal to 1, y equal to -3 and z equal to 2. Z is 2, y is -3, x equal to 1. So in this way we can easily solve the given system using Gauss elimination method. So this is the example in which we obtained unique solution. For every system there are only 3 possibilities. Either system has unique solution or no solution or infinite number of solutions. So in this case we are able to find out exactly one values for each variable, therefore solution is unique. We take one more example. Solve the linear system 3x1 plus 2x2 plus x3 equal to 3, 2x1 plus x2 plus x3 equal to 0, 6x1 plus 2x2 plus 4x3 equal to 6 by Gauss elimination. So this is a system of 3 linear equations in 3 variables x1, x2 and x3. They can ask this same question in this way also. Check whether given system is consistent or not. If yes, find its solution. So first we start by writing the augmented matrix. The augmented matrix is, so here variables are x1, x2, x3. So first column of augmented matrix corresponds to coefficients of x1, which are 3, 2 and 6. 3, 2, 6. Second column corresponds to coefficients of x2, which are 2, 1, 2. And third column corresponds to coefficients of x3, which are 1, 1, 4. One, 1, 4. And the last column corresponds to coefficients on the right hand side, which are 3, 0 and 6. So now we have to convert augmented matrix into row echelon form. So to convert this matrix into row echelon form, I have to first make these two entries 0. So for that I have to multiply first row by -2 by 3 and add in second row. Similarly, I have to multiply first row by -2 and add in third row to obtain 0 here. So if we apply these two operations, second and third row will change. So first row remains as it is. Multiplying first row by -2 by 3. So 3 into -2 by 3, that is -2, and plus 2, which is 0. Then 2 into -2 by 3, that is -4 by 3 plus 1, or 1 minus 4 by 3, which is -1 by 3. Then 1 into -2 by 3, that is -2 by 3 plus 1. So it is 3 minus 2, which is 1 by 3. and 3 into minus 2 by 3, that is minus 2 plus 0, which is minus 2. Okay, so now we consider this operation, multiplying first row by minus 2 and add in third row. So here 3 into minus 2, minus 6 plus 6, which is 0. 2 into minus 2, that is minus 4 plus 2, which is minus 2. Then 1 into minus 2, that is minus 2 plus 4, which is 2. 3 into minus 2, which is minus 6 plus 6, which is 0. So now in the next step we require a 0 here. So for that we multiply second row by minus 3, so that we will obtain 1. If I multiply second row by minus 3, I will obtain 1 here, and negative of minus 2 is 2. That means I have to multiply second row by minus 3 into 2, that is minus 6. So if I multiply second row by minus 6, then I will obtain 2, and if I add that 2 here, I will obtain 0. So we multiply second row by minus 3 and add in third row. So minus 3 into minus 1 by 3, that is 1, minus 3 into, we have to multiply with minus 6. So we can see minus 1 by 3 into minus 6, this minus 1 by 3 into minus 6, minus 2, and you can see negative negative positive, so we will obtain 0 here. So in the next operation we multiply second row by minus 6 and add in third row. So third row will change, this is 0 minus 1 by 3, 1 by 3, minus 2. Because of these two zeros there is no change here. Here we multiply minus 1 by 3 by minus 6, so we will have 2 and minus 2, which is 0. Similarly 1 by 3 into minus 6, that is minus 2, and plus 2, that is 0, and minus 2 into minus 6, which is 12, plus 0, so we obtain 12. So this is in row echelon form now. And we know that this column corresponds to x1, this is for x2, and this is for x3. So if we write down this system corresponding to this row echelon form, then the last row of that system is 0 into x1 plus 0 into x2 plus 0 into x3 equal to 12. This implies 0 equal to 12, so which is not possible. So we obtain contradiction, which is a contradiction. So therefore given system has no solution. No solution, because whenever system has no solution, you will have this type of contradiction. So 0 equal to 12 is not possible, therefore given system has no solution. And another thing is, whenever system has no solution, you will always obtain this type of matrix, you will always obtain this type of row. All the entries are 0 and the last entry, say 15, is non-zero. So if all the entries before the last entry are 0 and if last entry is non-zero, then if we write down the system corresponding to this, we will always have 0 equal to 15, so which is not possible. Therefore this system has no solution. So in this way, using Gauss elimination method, we can decide whether given system has a solution or not. In the next lecture, we will discuss the case of Gauss elimination in which we have infinitely many solutions. So I hope you like this lecture. Thank you very much.